A string can withstand up to 7.5 kilograms hung vertically on it, and then it breaks. A piece of string 4 meters long is used to whirl a 2 kilogram mass in a horizontal circle faster and faster until it breaks. Find various things. Now, the problem is this. We have only really discussed horizontal circles.
Glasses.
Safety glasses, right? For goodness sake, safety first. All right, we've only really discussed horizontal circles. Because what changes when you do vertical circles?
Gravity.
Gravity, right? Now gravity is acting down on it. In fact, and if you think about it, I'm doing some foreshadowing here. If I slow this down,
That's so cool.
the circles kind of breaks, right? That's like cool. Really? Of all the things I've done, that's the cool
Do it
thing.
again. Whoa!
I did that. Holy cow.
I'm pleased for you, Tyler. Okay, so my point is this. When you read the problem, you have to think, is it a horizontal? Is it a horizontal circle? Or is it a vertical circle? And this one has both words in it, doesn't it? Yes, it's hung vertically, and then it breaks, and then we're talking about a horizontal circle. So what this is talking about here, a string can withstand, and there's two masses too, right? A string can withstand up to 7.5 kilograms hung vertically. So in other words, just like in a fishing line, right?
Mm-hmm.
Correct? I think you fish. What is like a 20-pound test mean, Brett? It's rated for 20 pounds of force, right? Okay, so that's what this is. They're rating this at 7.5 kilograms. That's the maximum force, or the maximum mass that it can withstand. And I managed to put a knot in this. Okay, so the first thing you need to do is you need to figure out how much force that is. So weight force is mass times gravity. 7.5 times minus 9.8, which is 73.5. 73.5 newtons. Minus. So in other words, the maximum tension in the string is 73.5 newtons. Before it
Snaps.
snaps. Now, Brett knows the 20-pound test line. You can easily relay a 35-pound fish, right? Yeah, so why is that, you know? Like, I actually don't know that. Yeah, so like it's not like guaranteed by any stretch, is it? No, not at all. So, yeah, maybe it's survived 20 pounds and it might be 30, might be 40. Yeah. Oh yeah. Okay. Yeah, we just make them. A piece of string 4 meters long is used to whirl a 2 kilogram mass in a horizontal circle faster and faster and faster until it breaks. So how come if you go faster and faster and faster, eventually it breaks? How come? Because of more centrifugal force required to speed it up at that speed, right? Okay, so in other words, this is telling you the centrifugal force, right? That's what it's telling you. It's telling you the maximum force. So when it says find the breaking force of the string, well, there's your answer. That's part A. That's the breaking force of the string. Okay? Find the maximum speed reached before breaking. Well, which one of our new formula friends has a velocity, a v in it?
FC equals mv.
FC equals mv squared. Should I use the FC equals mv squared, or should I use the AC equals v squared over?
Wait, A equals what?
A equals v squared over r, right? Should I use that one, or should I use the FC one? Why FC? Because you got a centrifugal force, exactly. So FC is equal to, come on, Bennett, smart enough, right?
Yeah.
FC is equal to mv squared over r. So, now, is that a negative force? mv squared over r. Should that be a negative force? Well, the negative is just because of the downness of that force, right? But now we're talking towards the center. Does that have a negative direction?
No.
No. So it's just a numerical value of 73.5. So 2v squared over And now the string is 4 meters long. Is that the radius?
No. Yes. No, never mind.
So what is your answer, Tom?
Is it, that's how I.
The string is 4 meters long, which is giant.
Oh,
Right?
it'll be going.
That'd be the radius, right?
Yeah, I figured it out.
Okay, good. So yes, that would be 4. Right? Okay, so we're going to skip some algebra here. So V is equal to, you can do this now, that's going to be 4 times 73.5 all over 2.
And then get.
What'd you get, Danielle?
98.6.
12.1? And then equals, and then square root. Yeah. With some calculators, you can go square root first, but then you'd have to go brackets, and then end your bracket. Some, yeah, 12, wow. It's 4 meters long, like, that's a big string. You're whipping it. Whipping it real good.
You whipping it into shape?
Yes, you are whipping it into shape.
Oh my.
Crack your brother's back.
Where's that comedy show?
Right here every day from 2:30 to 3:30, right? Live in front of you. It's more of a dramedy.
Dramedy.
So what is the period of motion? In other words, what is the t value at break time? Now that doesn't mean like at 2:20,
This is the maximum speed right here.
right? We want to know the t value when it breaks,
Oh.
which is when it's going 12.1 meters per second. So which one of our formulas has a t in it? Yeah, or you could go t is equal to 2 pi r, or I think you got one too that's like this, right? V equals 2 pi r over t, I think too. You got that one, right?
There's so many.
This is
There is a lot, yep.
this is for
There's
salt
more
and
all of them ones that we can use.
I would say there's really only,
Like, are they just the ones that we like save?
yes, I would say there's really only 3.
I thought you said we were done with the same ones.
Yeah, I think this one you do need. This one is simply distance over time. That's all it is, right? 2 pi r, circumference over time. You might need an F equals MA, right? Yeah. Okay, so this would be 12.1 is 2 pi r. What was our radius again? 4? Over t. So t is equal to 2 pi times 4 divided by 12.1, which is 2.08 seconds, I think. You could use the other FC formula too, absolutely. Right. You should get the same thing. Yeah, of course.
Oh, we're doing.
Okay,
We're doing C.
that was C.
And B was the.
B was the speed. This was C.
Oh.
That was B. Okay, now you guys don't have this page, I don't think, right? So try to find a place to squeeze it in. The textbook does a nice little job of giving you, and you're going to hate me for this, a couple more formulas. Now, I always debate whether it's worth showing you or not, but I think I can leave it to you whether you want to use them or not. So remembering that t is equal to 1 over f, and the flip of that is f equals 1 over t. Just keep that in mind.
Can we write this down?
You know what? Wait till the end, and then you decide whether you want to write it down. Okay? That's okay. So, it could be used in, if I went v equals 2 pi r over t, instead of the over t, I can replace over t with just a F, right? Because F is equal to 1 over T. So over T can be replaced with an F. So V equals 2 pi R over T can be replaced with 2 pi RF. Now, the reason that that's helpful is if you have the frequency, then you can just fire it in there. You don't have to convert it to period. Right? Save a step. Likewise, A equals 4 pi squared R over T squared. You can replace over T squared with an F squared. A equals 4 pi squared R F squared. Remember those magic triangles they showed you back in grade 9?
Well,
With F.
chemistry.
Remember those?
I love them.
Yeah, well, try to come up with a magic triangle for 4 pi squared R F squared. More like a magic trapezoid. That's why I don't like the magic triangles. So, if you want, you can use those. If you don't want, just keep on going with the over T's. It's up to you.
Wait, like what?
Yeah, I want to go with the over T's.
That's fine. I'm not going to force you. Okay, so this actually is a textbook question. It's page 226 in the textbook. I'm going to give you a few problems to try in the textbook as well. So this is a 20-gram flea. Sorry, a 0.20 gram flea, like little teeny tiny bug, sitting a distance of 5 centimeters from the center of a rotating LP record. Now there, that dates you. I'm guessing that there only is one person. Well, no, that's not entirely true. Records are making a comeback kind of thing, aren't they?
Yeah. We
Yes.
have no record player.
Do you have a little record player?
I was
Yeah?
gonna buy one.
We have a little Christmas one that we play every Christmas.
Oh. I had a whole bunch of records and I got rid of them all. I saved one as sort of a souvenir and I kind of regret getting rid of them now.
Well, when did you say it?
I saved Charlie Sexton's debut LP. Very rare, very sort of, yeah. He's not dead. He was like 17 years old when he recorded.
Ooh,
He's like an amazing guitarist from
Hey, guess
Texas.
Malcolm Young guy.
I know. So did David Cassidy from the Partridge Family.
Never heard of him.
Mr. Bennett, what is LP stand?
LP stands for long playing. Because when records were first made, you could only put one song on a side, and then to make them longer playing, they put 5 songs on a side. Which would be like up to 45 minutes total full side. Yeah. There's also the little ones that were a single. They were a 45. You have one of those, a 45? I had a whole whack of those. I just threw those away.
People.
I know. So this particular record, now, if you go to like, we're talking probably your great grandma's house. Depending on you still have a great grandma around.
I do.
No. My children, my wife's grandmother's still alive, she's 102, so my kids have a great grandmother. She's 102.
I don't know.
She has a new record. But anyways, really old records were 77. Do you guys know what RPM stands for?
Rotations per minute.
Yeah, rotations per minute. So the big ones, the big records that you guys would have, the Christmas one, Megan, would be at 33 1/3. And then the small singles, they were 45. So they would go faster. The big ones would go a little bit slower. And you could, but my record player as a kid, you could change it, right? So you can put the 33 at 45, and then every song sounded like Alvin and the Chipmunks.
Yeah.
Yeah, you've probably done
You
that.
speed it up or you slow it down.
Yeah, exactly. Good fun. Anyways, none of this is relevant to the task at hand. Just Mr. Bennett's history lesson. What centripetal force must be provided by friction to cause the flea to maintain its UCM? So let's just draw a picture here. So I'm going to attempt to draw a picture of the Earth.
Ha!
There's the record with the hole in the center. And here is our little flea.
How did they win it?
I don't know. Good question.
Oh,
They killed him.
It's supposed to be a record. Now it's rotating around, right? So it's going like that. Now what holds the flea? If you imagine we're all on a big giant merry-go-round with, like, let's say the center of the merry-go-round is my lamp over there. Okay? And we're all going like around it on a big carousel. Okay, right? What would hold you in place here as we're going around?
Friction.
Friction, exactly right? Friction between your feet, right? Like if the whole thing was made out of ice, we would just all slide off the edge here, right? Yeah. Right? But friction would hold us on. So that's what they're saying here. What centrifugal force must be provided by friction cause the fleet to maintain its UCM? So you're trying to find
How much?
the FC. Okay, now Marley asked about any other formulas, right?
Wow.
Just give it. Why don't like at the beginning, just make a huge sheet of every single formula.
You go right ahead. Every one time I write something down, you should put it on your sheet. Oh, well, that's a good idea. Did you know when I first started teaching physics, I made kids memorize all the formulas?
Why that's me?
That's
That's reasonable.
There was, I think I counted, it was like 56 or something.
That's reasonable. Like
I
by the, I could probably name, like by.
All of your parents probably would have had to do that.
By the end of a unit, you can pretty much.
Absolutely. Oh, come on. Your mom's younger than I am.
I actually forget some of the basic ones.
Yeah? Okay, so let's figure this out here. So what is going to provide this friction? Well, if FC is equal to, hang on here, maybe we can do this, mv squared over r. Let's try to figure this out here. What do we know? Well, we got 5 centimeters. That's going to be 0.05 meters. That's going to be my radius, right? I'm going to try to do this without looking at my notes.
Okay.
The radius is 0.05. This is the... Now, should we convert that 0.2 grams to kilograms? Probably. So we're going to have to divide by 1,000. So that's going to be 0.0002 kilograms. But I don't have a speed here. Oh, but I got this number. What's 77 RPM again? Rotations per minute. Per minute. So 77 rotations per minute is 77 divided by 60, right?
Mm-hmm.
So what's that?
So we're trying to find time per.
1.28. That would be revolutions per second, which we know as the frequency. The frequency is 1.28.
Whoa.
FC is equal to mv squared over r. What can I do with frequency?
What's the unit for hertz?
Hertz. This is 1.28 hertz
Ouch.
is the correct unit, yeah. Okay. What if I look at one of these ones here? Oh, hang on. A equals 4 pi squared r f squared.
We're looking for what?
What are we trying to find? We're trying to find the centripetal force, right? So if I go centripetal acceleration is equal to, what is it? 4 pi squared r f squared was the new one, right? So 4 pi squared, radius 0.05, frequency 1.28, oh, and that's squared. So this is that new one that I just pulled out of my hat here.
Wait, I want to put those down.
So that's going to give me an acceleration of,
Why are we trying to find the acceleration?
well, what I'm really trying to find is the centripetal force. But hey, you know what? What if I just put, if I do this, remember I did this the other day? If I put a mass there, what does that do? Doesn't that make that force?
Mm-hmm.
Right? Remember we did that the other day? No?
And why would you?
I can do it another way if you don't like that way.
No, that's cool.
You like that? Well, we'll leave it like this. We'll leave it like this. Okay, but someone's got to work that out for me because I don't have my calculator. I left it at home.
2.3.
How much?
Came to physics class without us.
You know, at one time, I
get 3.3.
exam was pretty
No, his battery's dying.
Well, what if I write?
Okay, so let's try it here. 4 times pi squared times 0.05 times 1.28 squared equals 3.23. 3.23? You put 0.5. 3.23.
Oh.
3.23 meters per second. Now we can just do this. Now we got A, F is equal to MA, right? Hey. F is equal to MA. So my mass is my flea mass, which is 0.0002 times my acceleration. I'll let you guys figure that out. Well, no, I can tell you what it is, because it's 0.00065.
See, we always switch the letters around and then I get confused.
I got 3.
I got 3.
Now, all I really did was, like, this step here is really just doing this, is it not?
Yeah.
That's all it is. I'm just multiplying by the mass there.
So that's your final answer.
That would be the final answer. What's centripetal force? So you would need the flea would need 0.00065 newtons of centripetal force. And could the flea do anything about that?
Would you get,
Well, unless he like leans in.
Leans in?
Yeah.
So what was that different thing that you were talking about?
Just multiplying, put an M in front of there, which is exactly what I did here. I just, right? You just take the M, put an M in there, and multiply by the mass. It's going to give you the same number.
That's cool.
Hey, could you scroll to the top?
Oh, God.
I think I need to give you some time to work. Yeah, I think I do. I think I got to stop pushing. Okay, now in your package, do you have some problems to work on?
No.
Oh, really? Oh, that's.
Would you stop moving the
Okay, I got to go run them off.
What is
Eleanor?
I'll be right back.
I want to see this.
What?
What on camera?
Isn't it like, I think it's not.
Yeah, Mr. Lowe. See, I would have just failed and retook it because I was going to go with. I think you do on the exam as well. Who's not good at Jim doesn't know about. Yeah, before he's.
Yeah, we're not great.
What's field?
It's not hard.
Show up.
You literally show up.
Stop.
I'm reading it.
You definitely can.
I'll be like mine.
Well, they do. It's their fault.
Yeah.
And we didn't, we have to now run to the Oh, yeah. Part of it missing, like, you guys didn't even change each other.
You like me? They were, we got like 2 socks and all. It was so weird. You know when people are on the team, it's not, maybe they were one per person.
No, I like the jersey because it's actually green and last year's they had black.
Our religion is just.
On the green ones are black.
And then.
I'm a bummer. Wait, what?
It's like the pirates, and then the ships are like.
Oh, yeah, for what? But it's like the oldest pirate, right? And the original one, it's a lot like just sticking his mouth. Really, I perfect use it. Change from a lot of stuff.
From some fucking pirates.
Yeah, like this is like this much confused, right?
No.
Like when they got those black jerseys, they're like, oh my god.
Okay, so here's a fun-filled pack of problems. There's answers on the back and a link and a QR code. You can't do any vertical circles yet.
What?
So much for the.
So like I see number 12 looks like a vertical circle.
Number 9 is too.
Number 9? Number 9? No, that's like, that one still says horizontal circle, right? Looks like 9 and 12, there might be another one in there somewhere.
9 and 12, Johnson?
Can't do just yet. Yeah, so I'll give you the rest of this period. Oh, I'm still recording. I'll give you the rest of this period, and then tomorrow we'll have to do vertical circles.
So that'll be like,
Say again?
so like 3 more examples.
Yeah. I might have to leave out the flying pig this year. That'll be very disappointing.
Oh,
Oh,
sounds so
do
interesting.
everything, and those 3 days you're gone, we'll teach ourselves something extra.
Well, I gotta do banked and unbanked. See, the problem is I'm leaving Wednesday. I wish we had school Friday. I mean, the whole thing's a lot simpler. We might do the flying pig when I get back. How does that sound?
Okay. So then after. Oh, and then we still do the test.
I mean, it's good to, I can take off the flying pig question off the test. That's easy enough. But it's good to have.
Mr. Bennett.
We can like
Mr.
do
Bennett.
it after and then like do that question.
Mr. Bennett.
It's really, I'm not worried about the question. I'm more worried about sort of like the extra stuff you get out of doing it. It's not that